Good morning, students. So today we are going to discuss about expansion of the Taylor series as well as the Maclaurin series in real analysis. Okay, so here it goes the statement. The statement says that let f of x be a function. Okay, this is a function and this function is defined on the closed interval a comma b. Okay, such that the two conditions are going to satisfy. The first condition is f bar n minus 1 of x is continuous. Okay, the function is continuous on the closed interval ab and the function is differentiable on the open interval ab. Okay, if these two conditions are going to satisfy, then there exists a real number c and that c belongs to the open interval a comma b such that f of b is equal to f of a plus b minus a of f dash of a plus b minus a whole square by 2 factorial into f double dash of a plus and so on b minus a to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of a plus b minus a to the power n divided by n factorial into f power n of c. So this is the expansion of Taylor series that we have to prove. Okay, the condition says that the function should be continuous on the closed interval ab and the function should be differentiable on the open interval ab. Okay, if these conditions are going to satisfy, then there exists a real number c, that c belongs to the open interval ab, then this expansion. Okay, so let us prove the expansion, or let us prove the Taylor series. Okay, now let us define a function. Okay, let us define a function pi of x such that, so this pi of x is going to be, we will use the above equation only. Okay, so pi of x is equal to f of b minus, okay, f of b minus f of x minus b minus x into f dash of x minus b minus x whole square by 2 factorial into f double dash of x minus and so on b minus x to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of x minus b minus x to the power n divided by n factorial into k. Let me call it as equation number 1. So, okay. So, the above equation, in the statement, the equation says that f of b is equal to f of a plus of so on. Okay. So, we will consider the equation pi of x using the above, that is pi of b minus pi of x. That means we are replacing a by x. We are taking f of x here. Okay. To say f of x is the function. F minus f of x minus b minus x into f dash of x and so on. Okay. So, here this is our equation 1, where k is a constant. Okay, so where this k is a constant to be chosen such that pi of a is equal to pi of b. Okay, so pi of b is equal to pi of b. Now let us consider pi of x at b. Okay, so we are consider pi of x at b, which implies pi of b is equal to 0. Okay, so if pi of b is equal to 0, now from this condition, obviously pi of a is also going to be 0. Okay, so if pi of a is equal to 0, now the above equation, that is equation 1, becomes at the point. Okay, therefore equation 1 becomes at x equal to a. Okay, at x equal to a, that is pi of a is equal to, okay, that means we are replacing x by a here. Pi of a is equal to f of b minus, okay, f of b minus, replace x by a, that is f of a minus b minus a into f dash of a minus b minus a whole square by 2 factorial into f double dash of a minus and so on, minus of b minus a, replacing x by a at the point x equal to a, to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of a minus b minus a to the power n by n factorial into k. Okay, that means we are replacing the above equation, we are replacing x by a and we are using this condition, that is pi of a is equal to 0. That means this pi of a, this whole equation is going to be 0. Okay, now we will consider this equation. Okay, so this function, this expansion which is equal to 0. Okay, or we will take this the negative term to the right side. That means it is going to be positive. Okay, that is b minus a to the power n divided by n factorial into k. So we are taking this negative term to the right side. That means it is going to be positive. So b minus a to the power n by n factorial into k, which is equal to the remaining term as it is. That is f of b minus f of a minus b minus a into f dash of a minus b minus a whole square by 2 factorial into f double dash of a minus and so on b minus a to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of the a. The whole expansion we are going to write as it is. We are just taking the negative sign to the right side, that this is going to be positive. Or we will take k is equal to, simply this k is equal to, we will send this term to the right side. It is going to be k is equal to n factorial divided by b minus a to the power n and the remaining term as it is. That is f of b minus f of a minus b minus a into f dash of a minus b minus a whole square by 2 factorial into f double dash of a minus and so on b minus a to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of a. Okay, so I will call this as equation number 2. Okay, that equation 2 says k, that means k is equal to what? Okay, so I will call this equation as equation number 2. Now, by data, we know that f of x, f dash of x, f double dash of x and so on, f power n minus 1 of x are all defined. Okay, so these are all defined and continuous on the closed interval a comma b and differentiable on the open interval a comma b. Okay, that the statement says, that is f of x, f dash of x, f double dash of x and so on up to f power n minus 1 of x. These are all continuous on the closed interval a comma b and differentiable on the open interval a comma b. Okay, therefore pi of x is also, okay, so pi of x is also continuous. This is also continuous and differentiable on the closed interval a comma b and open interval a comma b respectively. Okay, so here I will take the statement once again. If these two conditions are going to satisfy, then there exists a real number c, that c belongs to the open interval a comma b. Okay, so here our pi of x is also continuous and differentiable on the open interval a comma b and the closed interval a comma b. Okay, then there exists, that is pi of x satisfies, pi of x satisfies all the conditions of Rolle's theorem. Okay, all the conditions of Rolle's theorem. Therefore there exists at least one point, that is c, and this c belongs to the open interval a comma b, right? So if this belongs to the open interval a comma b, such that, what is the condition? Such that pi dash of c is equal to 0. Okay, such that pi dash of c is equal to 0. Now, okay, we will use this condition later. Now, differentiating equation 1 we get. Okay, what is the equation 1? So this is the equation 1, that is pi of x is equal to f of b minus f of x minus. Okay, so I will differentiate this equation. Okay, let me show you. Okay, so this is our equation 1. I will differentiate this equation here. So pi dash of x is equal to, okay, pi of x is here, we are differentiating, that means it is going to be pi dash of x. So here f of b is constant, it is going to be 0. Okay, now minus differentiation of f of x is f dash of x. Okay, minus, so here it is minus of b minus x into f dash of x is there. That means we have to apply the product rule, that is u into v. Right, so that is u into v. If we apply the product rule, that is u into v, it is going to be, Okay, so I will show you here. So the function is here minus of b minus x into f dash of x is there. For this we have to apply the product rule, that is u into v. I will take minus as it is. The first function is b minus x. U into differentiation of v is f double dash of x. Okay, plus the second function, that is f dash of x into, here the constant is 0 and differentiation of minus x is minus 1. Okay, so this is going to be minus f dash of x. Okay, if we remove the negative sign, it is going to be minus of b minus x into f double dash of x, minus into minus, plus f dash of x. Okay, so the same term will continue here. Okay, I will write here minus f dash of x plus, so this is plus f dash of x minus b minus x into f double dash of x, and the next term, if we go on continuing like differentiating the function, it will become plus b minus x into f double dash of x minus and so on, minus of b minus x to the power n minus 1 divided by n minus 1 factorial into f power n of x plus k by n factorial of n into b minus x to the power n minus 1. So see here, so minus f dash of x plus f dash of x minus of this term plus of this term will get cancelled and so on. Okay, all the term get cancelled except the last two terms. Okay, that means we will get pi dash of x is equal to, okay, I will write the last two terms, that is minus of b minus x to the power n minus 1 divided by n minus 1 factorial into f power n of x plus k into n b minus x to the power n minus 1 divided by, here it is n factorial. We can write n factorial as n into n minus 1 factorial. Okay, so here n will get cancelled. From this term, we will take b minus x to the power n minus 1 divided by n minus 1 as common. See, so this term and this term will take as constant. Then the remaining term is including negative, that is minus f power n of x plus the remaining term is only k here. Okay, plus of k, that is pi dash of x. So here we have taken pi dash of c is equal to 0. There exists a real number c that belongs to the open interval a comma b. Now at x equal to c. Okay, at x equal to c, this is going to be pi dash of c is equal to b minus c, replace x by c to the power n minus 1 divided by n minus 1 factorial of minus f power n of c plus k. Okay, I will write which is equal to 0 because what we have taken pi dash of c is equal to 0 according to the condition. So I am taking this pi dash of c is equal to 0. That means b minus c to the power n minus 1 divided by n minus 1 factorial of minus f power n of c plus k is equal to 0. Okay, which implies minus of f power n of c plus k is equal to 0, or f power n of c is equal to k, or k is equal to f power n of c. So here we got the value of k that we have taken in equation 2. Okay, so here this is our equation 2, that is k is equal to this much. Okay, now we will replace the value of k here, that is k is equal to f power n of c. Okay, therefore I will call this as equation number 3. Therefore, from equation 2 and 3, therefore, from equation 2 and 3, equation 2 becomes, we will replace the value of k here. Okay, equation 2 becomes f power n of c is equal to n factorial. We'll just replace the value of k, that is f power n of c. Then the right part is as it is, as per equation 2. N factorial divided by b minus a to the power n of f of b minus f of a minus b minus a into f power f dash of a minus and so on, b minus a to the power n minus 1 divided by n minus 1 factorial of f power n minus 1 of a. Okay, what we have to prove from the statement? We have to take f of b is equal to, okay. So if we send this term to the left part and we will write the remaining part, we will get f of b is equal to, okay, f of b is equal to, this whole term is going to be positive and this is going to be, the numerator is going to be denominator and the denominator is going to be numerator, okay. That is f of b is equal to, the positive terms are going to be f of a plus b minus a into f dash of a plus and so on b minus a to the power n minus 1 divided by n minus 1 factorial into f power n minus 1 of a plus, so this term is going to be, okay, so the denominator is going to be numerator and this is going to be denominator, that is b minus a to the power n divided by n factorial into f power n of c. So this is the statement of Taylor's series of single variable, okay, so of single variable. Generally we use the Taylor's expansion, okay, generally we use the Taylor's expansion as y of x is equal to y of a plus x minus a into y dash of a plus x minus a whole square by 2 factorial into y double dash of a plus and so on. So this is the Taylor's expansion, okay. So this Taylor's expansion will convert it to Maclaurin's expansion when it passes through the origin, okay. That means it is going to be that the value of a is equal to 0. Then the Taylor's Maclaurin's expansion is, that is Maclaurin expansion is going to be y of x is equal to, okay, this is y of 0 because when it passes through the origin the value of a is going to be 0. So y of 0 plus, if a is 0 then the term is x into f dash of 0 or y dash of 0 plus x square by 2 factorial. A is 0, that means it is x square by 2 factorial. Then a is 0 means y double dash of 0 plus x cube by 3 factorial into y triple dash of 0 plus and so on. This is what the expansion of Maclaurin's series, okay. Now we will discuss one example based on the Taylor's expansion, okay. Okay, the question is like this: expand f of x is equal to x power 5 plus 2 into x power 4 minus x square plus x plus 1 in powers of x is equal to minus 1 that they have given, okay. Now the solution is like this. What is the given equation? I will write it is in terms of y of x is equal to f of x they have given. I am writing y of x, okay. So y of x is equal to, the equation is x power 5 plus 2 into x power 4 minus x square plus x plus 1, okay. At the point x equal to minus 1 they have given, okay. That means y of minus 1 is equal to, just replace x by minus 1, okay. So x by minus 1 is, this is minus 1 to the power 5, that is minus 1 plus minus 1 to the power 4 is, it is going to be plus. So 2 minus, again minus 1 whole square is plus 1. So this is minus 1. X is minus 1. So plus 1. So the value is 0 because plus 1 minus 1 plus 2 minus 2 will get cancelled. The value is 0. Now y dash of x, first order differentiation. So y dash of x is 5x power 4 plus 4 2s are 8 into x cube minus 2x plus 1, and y dash of minus 1 is 5 minus 8 plus 2 plus 1. So 5 plus 2 plus 1 is 8. 8 minus 8 is 0. Now y double dash of x. Y double dash of x is 20. 5 into 4 is 20 x cube plus 8 3s are 24 x square minus 2. So y double dash of minus 1 is 2. Okay. Similarly, y triple dash of x. Y triple dash of x is, this is 20 into 3 is 60 x square plus 48x. So y triple dash of minus 1 is 12. Now y 4 of x is equal to 120x plus 48. 60 into 2 is 120. So y4 of minus 1 is minus 72, similarly and so on. Okay, now we know the Taylor's expansion. The Taylor's expansion is y of x is equal to y of a plus x minus a into y dash of a plus x minus a whole square by 2 factorial into y double dash of a plus x minus a whole cube by 3 factorial into y triple dash of a plus and so on. Okay, at x equal to minus 1 or at a is equal to minus 1 is there. Now y of x is equal to y of a is equal to minus 1, that is y of minus 1. Okay, replace a by minus 1, that is the given value is there. Okay, so plus of x, minus into minus is plus 1 into y dash of minus 1 plus x plus 1 whole square by 2 factorial into y double dash of minus 1 plus x plus 1 whole cube by 3 factorial into y triple dash of minus 1 plus and so on. Okay, now which is equal to, now substitute the values. What is y of minus 1? Here it is, y of minus 1 is 0. I will write 0 here. Okay, plus of x plus 1 of y dash of minus 1. What is y dash of minus 1? Which is also 0. So this is 0. Okay, now plus of x minus 1 whole square by 2 factorial is 2 itself. Now y double dash of minus 1 is what? 2. Okay, I will substitute the value. Y double dash of minus 1 is 2 plus x plus 1. Okay, sorry, this is x plus 1. X plus 1 whole cube by 3 factorial is 6 and y triple dash of minus 1 is 12. Okay, I will substitute the value 12 plus x plus 1, the next term is going to be power 4 divided by 4 factorial. 4 factorial is 24 into x power 4 of minus 1 is minus 72. Okay, minus 72 plus and so on. Okay, now simplify. This is equal to, here that's 2 will get cancelled. So this is 6 ones are, this is 6 twos are, this is 24 ones are, this is 24 threes are. Then the value is, or the expansion is x plus 1 whole square plus this 2 into x plus 1 whole cube, okay, minus 3 into x plus 1 to the power 4 plus and so on. So this is the expansion of f of x is equal to the given function x power 5 plus 2x power 4 minus x square plus x plus 1. Okay, now the application is the Taylor series for a function is often useful in physical situations to approximate the value of the function near the expansion point x naught. And Taylor series approximations are used in both mathematical economics and economic theory of finance. They are widely used in numerical methods for evaluating a function around the particular value of its argument, consequently are discussed in every basic calculus books. Okay, so this is what the expansion of Taylor series and the Maclaurin series and based on some problems. Thank you.